Hello, this is Kyocha Shen and welcome to my assignment 2B project video where I would be discussing all of the aspects of the game that I have submitted called Legacy Savers. So as an introduction, what exactly is Legacy Savers? Legacy Savers is, well, basically a game where you as a player enter the premises of a book presumably damaged in order to restore it to its former state so that you'll be able to read all of its contents from start to finish without any errors. So to start off, we'll be talking all the way from the start screen all the way to the boss level, the three levels that I have defined already and submitted. So as you can see here, there's a bit of animation, there's some music. They are fairly simple in all honesty. They're fairly simple in all honesty. It doesn't really take too much effort. It's mostly just setting some screens on and off and playing the animations using set trigger, set move, as well as the animator, as you can see here, this animator stuff. So by using an animator as a state machine, there's a bunch of other stuff that I could do, which I'll talk about later. But for now, there is a reason why I use start coroutines here and a separate method just to trigger the start coroutines for two reasons. Firstly, buttons cannot trigger coroutines, these IE enumerators, so I need a separate method that the buttons can trigger in order to trigger the coroutines itself. Secondly, the reason why I use coroutines is so that these animations will have some time to play out first before I do a bunch of that, switching screens and loading the other game levels, so the player will actually be able to see the visible change instead of having it try to play the animation, then immediately move on to the next screen, and hence prevent the animation from fully playing. So if we go all the way to the game level here, this is actually, as you can see, we actually start off with a dialogue system here. So how this dialogue system works is by using a few things. So most importantly, there is a bunch of stuff that I'd like to show you first.
When you're speaking to people.
Okay, so basically, what I've actually done for this dialogue manager is I actually referenced a bunch of
Hey everyone, my name
this one YouTuber. It's basically the video done by this guy called Trevor Mock. So it's Unity Inc. plus Inc. dialogue system. This is how I actually used it to. It's actually how I got most of my code here. So if you are to reference it, you can probably just look it up and then just go from there really. So just to go through it, there's a bunch of start functions, which basically turns off the dialogue when needed and turns it on when it is played. Initialize audio for dictionary. All this does, it simply stores all the information for speaking sound effects. So it stores the scriptable objects. And what these scriptable objects are is they are basically presets to determine who is speaking, the ID, what sound effects are going to be played, stop audio source. This is mostly to prevent audios from looping. So for example, if I play sound A and I play sound B immediately after, I will turn off sound A, then play sound B instead of having both sound A and sound B playing together. And this frequency level basically determines how often the character actually makes a sound. For example, if there is a ... U, then if it's frequency level 4, that means ... then it makes a sound at U. So it's very simple there. So set current audio info, it's mostly code that I'll be talking about a bit later. So for update, enter dialog, we'll start enter dialog mode. This is to mostly reset everything. And it'll start with continue story. So first of all, this piece of code basically checks if there is a next line to be played, because what I'm actually using are Inc files. Now, Inc files is a package software that makes it very easy to type out dialogue as well as do relevant tags. And these tags allow you to do a bunch of stuff like determine what is the name, the text, the image, and as well as certain layouts that you might actually have. So how the display next line works, the current continue story, is basically it checks if there is a line to be played. For example, if this is the first line and continue story is run, it basically checks if there's a second line. So there's a second line here, yes. But if you're on here, it checks if there's a second line. There is no second line here. It says N, and basically it exits dialog mode, which pretty much deactivates the whole system and resets all the information. So if that's the case, display line now, stop coroutine. So what this basically does is something I'll explain a bit. So first of all, handle tags. So this is basically the code that determines what kind of information goes into my system. So according to it, by simply grabbing all of this with the hashtag and splitting the information through this sign into two values, a tag value and a tag key, I'm able to determine what exactly should be played and where it should be played. For example, if it says it's a speaker tag and the speaker tag is a string that stores the tag speaker, as you can see here, speaker, then it will grab the tag value, which is U, and it will set the text, which is display name text, this U function here, as you can see here, display name, it will set it to U. Then for layout tag, portrait tag, layout tag is basically to determine one is to left, one is to right. And we also have a portrait tag, which basically shows this little image based on a bunch of files determined in dialog sprites. It basically loads in all of this. But how it's actually being specifically done, that was the source material. This is the actual image. These animations are all played, which are just single framed, unlooping animations. They are just playing to load the thing in specifically. Then we also have an audio tag, which basically determines who's speaking, and this is just the default. So the audio tag set current audio info. This is fairly simple. I've already more or less explained it. It determines who is actually talking based on the ID value derived from audio default, which is a string, and then it basically looks for it in the array that is found here. It looks for the array. So this array stores every single possible entity that could ever speak, and this is just the default setting. And since the player already has the players already automatically set as the default because the player will always be talking, there isn't really a need to add them to this array here. So now let's move on. So how does it actually display the text itself? So by displaying line. So what this basically does is for each character letter in line to character.array, it adds one letter. It displays the letters one by one. For example, if I were to look here and it's WHAT, instead of adding the entire word to this dialog system, for example, it just spawns what it does instead is that it spawns in the letters one by one. So it'll spawn in W, wait for a bit, H, wait for a bit, A, wait for a bit, and T, wait for a bit. As you can see, it's slowing. So there is a bunch of other functions as well. For example, a fast forward button. If you were to press space, while there's some letters shown, it will immediately fill out the rest of the line. A bit like this. Something like this. But because the space key is also linked to a little bit of code called continue story, which basically loads in the next line, I needed to make sure that it will not register a double input. So both of these variables will not be automatically set to true. So the moment I move on to the next line, it will not fast forward the rest of the line. So this is done by having a number of letters shown, which basically keeps track of the number of letters that have been added to the dialog. For example, but something, it will keep track of the number of letters, the count in this array. And when it keeps track of the count in this array, since there is like definitely more than 7 letters here or 7 spaces or slots, it allows you to skip to the next line. And this dialog sound and this typing speed. This typing speed is mostly just to put some space, just so it doesn't spawn everything too quickly. And once it's done, there's a set active true just to show that you can continue and play dialogue sort. So what this basically does is that it grabs a list from it grabs a list and adds a bunch of the sound clips from this array into the list. And what it basically does is that it randomizes it according to a frequency level and a current displayed character count. So what this basically does is that it creates a varied rate of speaking. So it randomizes between one of the three sound clips and then it just plays one every time the speaker talks through a random index here. And what this basically does is that it makes sure that, for example, so this is a modulus. So this basically makes sure that there's no remainder. So for example, if the frequency level is every three letters, this basically makes sure that for every three letter that spawns in, it spawns in once. So if it's 4, 5, 7, 9, 4, 5, 7, 8, it basically grabs a remainder. And because there is a remainder from this modulus function, it does not speak because it is not the third letter that has been spawned yet. So it has to wait until that happens. And then if we were to move into this little code, this basically allows you to continue the story if the line has been filled out. So that means even if you spam space, it will not allow you to move to the next line until this little spacebar shows. So once this whole line is shown, then you can move on to the next line with pressing space. And one more thing here, as a little bit of an Easter egg, I did add a skip button which will immediately trigger the exit dialog mode, which basically deactivates the whole system and resets everything. So if I were to press S, it clears everything. Now this is a help menu. Since I didn't actually have the time to set up a tutorial level, I decided to mostly just set a help menu here. So it's mostly just a bunch of text to guide the player accordingly. And how this is actually being done is that it actually uses these two buttons, a next page button and a previous page button. So what they store is a page switcher script. Now, firstly, this variable basically determines if you move to the next page or the previous page. So what it basically does as a fundamental basis is that it stores all the possible pages within the array and it loops through them. So for example, if I'm on the fourth page and I press the next button, it basically notes in the next page in the array by setting everything else but that page to inactive and setting the page that is going to be loaded, like the fifth page, to be active. And there is a little tag here. All I simply did was that I accessed its text mesh pro component and I just updated the text itself. And just in case this page number +1 is added, because of the fact that the array starts at 0 instead of 1. And since there is no page 0, I decided to add 1 as a base level. So 1, slot number 1 for page 1, slot number 2 for page 2, and page length to string to basically keep track of how many pages are there in total. So it's fairly simple. So all I have to do is press X. Now, this dialog system is actually the core component of my game itself. This rhythm system. So as you can see here, there is a bunch of notes here first. So how do these notes actually spawn in? So because there is a rhythm system, I need a way to create a consistent beat. So how I create a consistent beat is simply by instantiating the notes at regular intervals, as shown here. So what they do is that they instantiate a prefab, and this prefab, as you can see here, is stored here. So let me just show you the prefab. What it spawns is node sprite and node sprite 1. Now there's a reason why there's two different variables, because there is some certain sets of scripts that doesn't necessarily need to be added to the whole system. So I don't need to run certain codes twice, which I'll explain in a bit. So there is a little bit of code here, and this is actually fairly simple. So all that this code actually does is that it simply looks through each and every single piece of nodes. So basically what it does is that if dialog is playing or if the tutorial is playing, it looks for everything with the node tag. So as you can see here, there is a note tag here, and it looks for all of them, sets them to array, loops through them, and deletes them one by one. So with that said, let's move on to the node sprites themselves. So as you can see, it's fairly simple. It's just a circle with a triangle. Though there isn't really a second. As you can see here, because it's on a canvas renderer, it will not really show as a default value. So these nodes are fairly simple. All they simply do is move to the center position. And once they move to the center position, it destroys the game object. So because just so it doesn't clutter anything. And one more thing, when it actually spawns in the nodes, it stores it here for easier sorting. It just moves to the center and it naturally deletes itself. And this basically is to demonstrate a missed beat. And this bunch of code is to just show if the dialog is paused. If the dialog is paused, it sets its speed to 0, stores its original speed in a separate variable, and once it's resumed, it grabs that speed and it just carries on like normal. Now there's a bit of conflicting measures with this little part because it's going to be deleted anyways. Why stop their speed? Now this is actually unfortunately because I wasn't actually able to properly implement this, because if I use the code called time scale to pause the game, it will prevent animations from playing, it will prevent any follows from playing, which is how I got my text effect and my speaking effect. So I needed a separate pause system. Now, because like if I were to ultimately just stop the node spawner from spawning, what basically happens is that since all the nodes are frozen, it spawns in one more node regardless of when I pause the system, and then it will create an irregular beat, which will really just mess everything out. So I decided to have these two as separate, which I would fix after the assignment itself, because I actually intend on continuing the game when I have the time later in the future. So these basically move to the center. These are basically your targets. So if you pay attention to the help menu, you would notice that there is a strike zone here and there's the guide. So how this basically works is that I have a bunch of colliders, this strike zone colliders. And these strike zone colliders basically detect if this node is colliding with them. And how this is being done is that this has a rigid body component as well as the node sprite in order to detect collisions between the node and the strike zone. As you can see here, this is a collision. So let's see. Let's take a look at the script itself. So this is mostly just a on trigger enter and on trigger exit. Now, how do you get rid of the nodes to prevent them from getting to the center and instantiating it as a missed beat? It's simple. All you have to do is make an input when it is colliding, and it will automatically delete sprites. Now that's actually very simple. Now with that said, let's talk about the other aspects of the game UI. There is a fever bar here, which basically rewards you to making inputs to the beat. It's fairly simple, which basically uses a fill meter. It basically uses a fill meter and it grabs two variables that store a percentage variable, and that percentage variable is what determines the fill amount. And there's a bunch of else statements just to make sure it doesn't go below 0 and above 100, due to the fact that there's a -10 and +5 instead of +5 and -5, which would accidentally make it uneven. And let's say if the fever amount was at 5, if I -10, it goes to -5, and it basically ignores this piece of code. This will not stop it from going below 0 itself. And this use fever here is fairly simple. It just heals the player, which I will actually now talk about in this health system. So what this health system is actually going to do, it's fairly simple. It's just a bunch of lives which store hearts, and these hearts are determined by player life, and this player life is stored here. So this determines the current health and the maximum amount of health. So for each heart, it stores 2 HP. So if it's 2 HP, that means it creates 1 heart and it sets it to full to 1 heart. If it's 1 HP, then it stores a half heart. But what it basically does is that it creates all the empty huts first, then it determines what's supposed to be through this little for loop. And this player dies, basically does a check to see if the player's health is 0. If it's 0, I deactivate the player controller to prevent the player from moving while they've died, because that would be incredibly dumb to have a corpse moving about like that. Trigger some animations, trigger the win lose screen, update it to show that you lost, wait for a bit to let everything else play first, and respawn the player by reloading the entire scene. So this is actually fairly simple, all this stuff, and clear huts is mostly to destroy everything when needed. So these create empty huts basically instantiate a bunch of stuff here, and it creates their necessary components. So what exactly is the hut component? It's a canvas item that basically stores a little script called help hut. Now what this help hut actually does is the following. It basically uses a switch and a public enum to determine what it's supposed to be. So this public enum is actually there for easier categorization. So if it's empty, hard, full, instead of 0, 1, 2, you'll be able to easily tell what it's supposed to show. And by storing the sprites here, you'll just be able to change out the sprites whenever possible. Now there is a separate system that's also quite similar. If you were to look here, the enemies also have huts. Now the only difference between the enemy hut system and the player hut system is the fact that the enemy hut is using a sprite renderer, because these huts are part of the game UI and these huts here are part of the game world. Now here's basically the item controller, which I'll show you in a bit. This mini-map is actually fairly simple. It's mostly done by using a separate camera that just detects only two things, the environment and a minimap variable. So how I have the minimap variable is I go to player sprite and minimap icon. I basically hide this behind the background. I hide this behind the background by setting the order and layer to 0 for boundaries, and since boundaries is below background, it effectively hides the minimap icon. So by doing this, I would effectively allow the player to be seen on the minimap. There's a blue circle to represent the item and a red circle to represent enemies. So that's actually fairly simple. And there's also a simple toggle function that mostly just to show and not show the minimap icon. So how do I actually move the player itself? Now that's actually, I'm going to be talking about it. So if you go here, by using input access value, which basically takes in inputs from the left right arrow keys or the AV arrow keys, it basically determines if, did I press the key? Was I not holding it down? Is it actually successfully hitting because it grabs from the node strike? And has the player already moved? If that's not the case, then I delete the nodes, basically, so they don't go to the center, and I move the player. Now, I will be talking about this later when I talk about the enemies a bit. So if I were to ignore this, determine player direction, what it basically does, since input axis value based on the input.axis horizontal is based on -1 to 1, I basically use it to determine where the player goes for vector 3 left and vector 3 right. So let's talk about the original position and target position. So this is basically determines where the player goes. So original position by target position by multiplying the direction value by 2 and adding it to original position. This basically makes sure that the player moves 2 square spaces. So if it's here, it would move here, it will land here. So it's now here. And we have a bunch of these raycasts. So since I'm actually moving in that manner, I need a bunch of raycasts to prevent the player from falling off and colliding with the incorrect enemies. Due to the fact that the player has a rigid body, any unintended collision could cause the player to shoot up, and once they shoot up, they won't actually be able to go down and hence destroy a bunch of collision and might accidentally get stuck. So if let's say I have a bunch of collisions, if the player is going to collide the enemy, instead of colliding the enemy, it attacks the enemy, allows them to act, and a bunch of other stuff like checking for boss, enemy zone, this will be important later, and the collider, which is basically just to check for map edges. So the space here, there's a collider here. If you were to pay close attention, you can see it here. As you can see here, you can actually see it here on the midi-map because the boundary is actually shown in the midi-map. So if that's the case, it sets the movement through lerp, and why is there this little function here? So the reason why there's this little function here is to make sure that the player moves smoothly by slowly increasing the percentage value in which the player moves. So elapsed time. So if it's 1%, it only travels 1% of the way, then 2%, 3%, 4%, and all the way through using the time dot delta type. And there's a bunch of animations here just to play through. And once that's the case, it allows everything else to act next. Okay, so as you can see here, you will notice that there is a turn system that's supposed to be used. And honestly, this turn system is fairly simple. So the first thing it does is that it grabs all the enemies, grabs all the projectiles with find objects with tag, and puts them into a list. Now this is going to be important later. So we have this setup turn order, which is the main manager of all the code. So how this actually works is that based on this little state variable here, it determines who gets to go. So if it's the player that gets to go, player moves, enemy, projectile, boss. Now, how this is actually supposed to work is that there's a bunch of else if statements. So if the player cannot move, then it moves the enemy. If enemy cannot move, then it goes to projectile. If projectile cannot move, then go to the boss. So this is to make sure that everything does not move at the same time, and it gives the player a bit more leeway to act first and have the enemies act later. So this is important for collision purposes, because if there is actually a singular space between the player and the enemy, for example, if I have to treat this little portal as the enemy, it basically makes sure that the player moves first, then the enemy checks if the player is in front of them, instead of having both player and enemy check in front of them, have it clear, they move to each other, and there'll be a collision, which is actually going to be a small problem. Okay. So this is actually fairly simple. So how do they actually run? Because there are multiple instances of the whole thing, what I basically do is that I look through each and every one of them, and I do a bunch of code that triggers the necessary code needed to allow the enemy to move. It basically tells them, hey, it is your turn now, go do whatever you want for this turn. And the reason why I added a list is because originally I had a global variable which determined when the enemy was actually able to move. Now the actual smallish problem with this was that if the first enemy moved, they deactivated the global variable since it's under update to prevent it from triggering multiple times. But the moment it does that, everything else is unable to move because that global variable is now off. Hence, I decided to switch to a list system. And we also have a bunch of checks for no, just to make sure the system is still able to work, even if there is no boss shown in the level. So we have this teleporter system here. This teleporter system here has a bunch of animations that is mostly done through grabbing all these images, throwing them in the animations, setting it to idle, and yada yada yada. As you can see here, portal idle, portal teleporter. So this is basically the teleport animation. So how does this work? Give me a second to show. So first and foremost, we have a bunch of these teleporters. So these teleporters basically only have two things, a collider and a bunch of destinations. Now there could be more than one destinations, but all that this does is that it stores a transform variable. So for example, if it's same floor and it stores to 1, so this basically stores the destination for this. And this stores the destination for this. So if I were to approach here and I want to use the teleport and only this script exists, it will just move me to wherever it's supposed to be. So in this case, here. So how is this actually done? Now that's fairly simple. It's simply by using a bunch of key inputs. This is simply code that just allows for ease of access, really. And this is the else if command. So in order to make sure that if to allow the player, because if you were to look at the game map, the player can go up, down, left, and right. So I basically used a secondary input. So E, W, E, S, and E, E to determine if the player goes left, right, up, down, so on and so forth. And any other input, deactivate the whole system. Teleport input. All this does is that it simply grabs the teleporter component needed. It grabs the animator to play the teleport animation, and it retrieves the destination from this component, and it teleports the player to that position. And that's pretty much it. And this on-trigger collision to these actually more or less just exist to make sure that the player doesn't accidentally, you know, teleport to teleporter they've previously teleported when they want to move somewhere else. So for example, if I were to move from here to here and I were to move to this teleporter, it basically makes sure that I do not move from here to here on sheer accident. Or the player doesn't just move front back, front back, front back, and constantly teleport from one place to another. So that's mostly what it does. And we have item counts. Now these item counts are fairly simple. The items actually in terms of prefabs is mostly the same. The controller, it's the same. It's pretty much the same code as the HUD system. It's pretty much the same as this, but with a few other stuff to determine what the item is supposed to do. Because they are more than just lives, they are items with various effects. So when a player collides with them, it adds them to the system and it destroys the minimap icon. So it is important to destroy the minimap icon so that it doesn't actually show that there's an item on the map that they haven't picked up yet, when they've actually already picked up an item. So it doesn't just add a random item here. It's like confusing the players, like, oh, where is this supposed to be and why is it following my player? This basically prevents that. So once it's done, it's set to transform position. It just makes sure that it spawns the item here, sets it to the parent for easier sorting. And a bunch of other stuff like current items, item slot. So we actually have this pencil variable here, which updates. Because the pencil is actually a consumable, I actually added some text to ensure that it keeps track of the number of items that actually spawn in by updating it. So for every time I add the pencil, I just update its count by 1, pretty much by retrieving its value. And that's about it. So this basically determines the items. So this ensures that the item will always be shown in the UI. This just basically shows that, hey, I have a shield, now I can use the shield function. I have a sword, I can use the sword function now. Now this shield function will be determined in a bit. The shield's actually fairly simple. All that it does is that it triggers a variable to make sure that, okay, to pretty much give the player invisibility so long as the shield is on. It's just triggering one singular variable. It's not actually any more complicated than that. So we have an item manager just to store a bunch of static pools, because this is standard across the enemy. There's only going to be one pencil type, one shield type. There's only going to be one player that's going to have these items. So as you can see here, it attacks, and this attack animation is done by simply drawing a little circle using a physics 2D overlap circle OR and checking if it collides with the enemy. In the event it collides with the enemy, then it deals damage to them. And we also have a restore function here. So if the player were to collide with the enemy zone, what this basically does is that it looks through their items. It basically checks if you have any items in your inventory. If you have no items in your, if you have no pencil items in your inventory, you're not allowed to restore the area. And how you're supposed to do it is, if you kill the enemy, the damage area that you see here basically turns white, and that becomes a restorable state. It basically represents a blank piece of paper. Now, how this blank piece of paper works is that It stores the player variables, and by using this, if it collides with the patrol zone while it's in a restorable state and we have a pencil, we basically delete the entire game object because the enemy prefab is this entire thing. So we need to make sure to delete this entire thing to prevent accidental collisions. So there is a finalizing update pencil equip, mostly just an update to text the GUI components and check if all areas are restored. So this is actually the win condition here. So what this basically does is that it loops through one thing. Because all the enemies will be dead by the time the entire area is restored. What I did is I make sure that to check if this enemy dead. If all of them are dead, then I say that the player is cleared the level, and I activate an exit that would allow the player to go on to the next level if they were to collide into it. It's fairly simple in that regard. And this on draw grips was selected, as you can see here, according to my comments. Here's to show the player attack variable. It basically just draws the player attack. You see, this little circle, it's just there to show you a visual aspect in the scene view, mostly for programming sakes, to show that, hey, this is actually colliding. So after we move on to the play combat, let's actually move on to the enemy, which we talked about. Because if we kill the enemy too fast, we don't actually get to see. So let's look at the enemy. There are 2 patrol points, which basically determines how the enemy moves. So there's 2 ways, 2 behaviors as to how the enemy moves. One is chasing player, where it will always follow the player within a certain distance. So once it's far away, it moves back to a patrol route, and this patrol route basically determines if the player moves. So all it does, it just has the enemy move from here to one patrol zone, turn around, and move here. Now, how's that actually being done? It's by using mouse movement. Now, first and foremost, by using the start system to have the animator as a state machine, because these play the animations and it just shows the natural sprites, I can basically use this as a very easy state machine. So process enemy turn, like I said, in a turn system, this basically tells the enemy that, hey, I'm going to see if I can move now. So this delay is just to make sure that to slow down the enemy, prevent them from giving more time. It basically just gives the player more time to act by adding a little delay. And as you can see here, this is their attack function. So if the player is close enough to the enemy, it basically makes sure the enemy is facing the player and it has the enemy attack the player. And this will be talked about after I go through its behavioral script. So this behavioral script is by using vector2.distance, it detects the distance between the player and the enemy. If the player is close enough to the enemy, it sets its chasing to true, and it allows the player to keep chasing the enemy. And these patrol destinations here mostly just tells the player, hey, I'm already at my destination, move to the next site. And this track down player is mostly for chasing script. So if the player is being chased down, it determines where the player is and it has the enemy move to the player accordingly. So the movement script, mostly pretty much the same as the player and with a couple more ray cards, mostly because of the fact that I cannot use a collider to prevent the enemy from colliding into unintended areas, because this is the whole point of this is to prevent the enemy from going where they don't need to be. So I can't actually create a collider because that will create some issues with the collision system, because the player will be colliding into an area that the enemy is trying to detect. So by drawing a line, it actually just splits up the whole system a bit more. So with that said, let's talk about all the attack variables. So firstly, we'll go for the default monsters. So there's a bunch of stuff which has take damage if the player attacks them, it takes damage, minus their health, updates their hearts, same as the player, and if that's less than 0, they die. So this basically prevents them from moving or dying. and if we have a duster item here. So how this basically works is that if there's a very specific enemy type that is killed, it basically triggers an animation that visually shows that the player has been inflicted with some kind of debuff. In this case, it is a slow debuff. So to visual aspect to this, which I will show when I play the game. You can see what this basically does is that it hinders the player movement for 3 turns. So this is actually fairly simple. This is what this piece of code does. So all this does is that if the player could make 2D inputs to move right 2 times, with this flow debuff, they are only allowed to move 1 time with 2D inputs. So, and with that said, each time that the player actually moves while under a debuff state, it adds 1 to a counter. So if the counter reaches a certain amount, it expires the counter, and the debuff is turned off effectively. And we have a bunch of stuff just to make sure that enemies die. A book damage controller, which basically updates the sprite system. Same as the items, really. It's just more copy pasting because it's fundamentally doing the same thing. Waits for a bit just to show that there is a death animation and destroy the game object. And we have the attack here. So all this does is that there's a monster signal just to show that there's an attack area, the white box that you actually saw earlier. So that just shows, hey, if you're gonna stay here and you're gonna do nothing, you're gonna get damaged. And if that's the case, it attacks the player. And there's a launch firewall for a different enemy type. So what's actually important here is that if we look back to the move to center, there's a bunch of code here. So what happens if they move to the center? Everything but the player is allowed to move, which basically is a penalty for the player for not timing their inputs to the beat. So all that this does is it just checks for range, checks if there is a fireball that can be shot before trying to shoot a fireball, because it's literally like trying to shoot an empty gun. There's no use in shooting a gun with no bullets. And if that's the case, there's a bunch of charge time variables, and this is to make sure that this happens. Once that's the case, launch fireball, set trigger. Let's see. Okay, so what this basically does is that it takes the list, all the fireballs in the array of the prefab, so it looks for this, and it looks for anything that is inactive. If it's inactive, it sends it back, grabs it from the array itself, and has it activate and determines where it actually goes. So as you can see here, fireball array. While there is only one fireball here, in the event that I wish to add more, this would be fairly easy simply by chucking in more fireball animations instead of just remaking the entire code. So how this fireball works is fairly simple. It moves the same like the enemy, has the same direction code as well. And the only thing that's even remotely different is 2 things. Firstly, there's a lifetime variable, which basically determines, if the fireball moves 3 times, does it just fizzle out and expire? Because even arrows will eventually fall if they are shot far enough without hitting anything. And secondly, we have a distance. So if the fireball is close enough to the player, it explodes. Check if the player is shielded. If it's not, then that's gone. That's very simple. Set trigger, explode. Set trigger, explode. So this is actually very simple. So with that said, I've talked about all of the enemies, the fever bar, the player, the notes, the hearts, the items, the help menu, and Now I shall talk about scripts. The sprites, which are mostly derived from three places. Unity, uh, from gameart.org, which is basically this fancy little website that actually gets you a bunch of free assets, which is incredibly useful. I cannot thank this website enough, and a friend that actually helped me draw a bunch of these sprites. So I'm actually fairly grateful to them for actually doing that. So with that said, I've actually talked about everything about the whole system. Oh yeah, there is an audio manager. It's just fairly simple. It just stores an audio source, plays the music. If there's tutorials playing, if there's dialogue playing, if there's anything else that's playing, it just pause and it just plays. It's just mostly background music just to create a sense of rhythm. Now with that said, characters, prefabs, animations, all of these animations are actually stored here, which actually gives them a bunch of life. Set scenes, characters, prefabs, and all these prefabs are mostly talked about already. This player UI is basically the same as this entire system. It's mostly there because this is the same system that's going to be carried over to every single level, so I preferred it to be as a prefab, as well as the managers here, enemies, enemy parts, teleporters. These are basically store all the important stuff that I need. So these are my scripts, start music, the ink package, dialogue, a bit more. So let's move on to the boss level. Now, if you were to notice, there is actually a substantial change in terms of aesthetic. So the reason why this is the case is because since this is a boss level, and the whole goal of the game is to fix what has been broken, I like to use this to represent why exactly it got broken. Because this story is about a knight who saves a princess from a dragon. So if you were to actually look closely at the text that's being shown here, which goes from start, top to bottom, just like how you would read a book from left to right, in this context in English, then you'll eventually find out why these books got damaged in the first place. So this boss level is meant to represent you going into the source of the problem and you fixing the source of the problem, which in this case is the main protagonist deciding to kill off all the important characters. Hence, because this is where everything goes wrong and everything takes a turn for the worse, the music takes a turn for the worse naturally. So the boss actually has a few things to be had. So it's mostly the same as the enemy because it's supposed to be a collection of. So what this boss is supposed to do, it's supposed to take aspects from every other enemy. So for the Ripper enemy type, it also has its attack animation, it has fireballs, and for the Dust enemy type, it does have a debuff, though that debuff isn't actually going to be used, mostly for balancing purposes. So what exactly makes the boss different from the regular enemies? Well, two things. Firstly, instead of a raycast to determine if the boss is actually far enough, if the boss is actually close enough to the player, we have this detect who collides, which has this attack point just to determine if the player is within the attack range. Because there isn't actually many other colliders inside this, it's fairly easy to just throw it in because it doesn't just prevent unnecessary collisions from happening. So we actually have this little slash animation here. Oh, that's actually for the boss. We have the attack area, boss attack area, default, which is pretty much the default. The only reason why I use default is because there has to be a base variable for all of this to function. So I do not want it to play any other animations as a default. So I do not want the boss to immediately attack at the start. So I need something as a placeholder. So hence there's a default animation there. So outside of that, there's also something called line jump. So because this is the boss, I don't actually want it to be too hard. So it firstly does two things. One, because if since all enemies are usually restricted to the line they are on, I granted the boss the ability to move from line to line. And if the player wants to be cheeky and tries to get above here or below the boss, then I will have the boss adapt accordingly, which I will show a bit. So if you pay very close attention to this map here, you'll notice that it moves. So how this moves is by using the same code that the player uses, but instead of having player input, it just automatically teleports the player. So detected collider and update. So else if current teleporter is not equal to now, it basically does the same as the player. But because this is automatic, I also needed to add in some variables to make sure to deactivate it, because the moment the boss collides with teleporter, so if the boss were to, okay, let me just move the player UI a bit. So if the boss were to collide with here, it teleports here. But since it's now colliding with this one, it'll teleport here and it will go into a constant feedback loop. So I needed to trigger a variable to say, hey, once I teleport here, I will not allow you to teleport again until you leave the portal and go to another one. And then secondly, what it does is that it does a bunch of math to check if the boss is below or above using the Y position. If that's the case, it plays the animation and then it teleports the boss. So why didn't I move the boss through animation? Because of how I did the movement script, by moving the boss through surely just animation, what happens is that it freezes the enemy, it prevents the enemy from moving naturally. So hence what I had to do was that idea to put the actual boss object and the boss sprite itself, the one that's actually going to be playing the animations and all, onto a separate game object that's a child. So let me just quickly show you. As you can see here, it's now above and below the player. So all this is the fairly simple stuff. So let me just now you notice this white star that actually appears. So this is the third thing that's actually different about the boss. So every time the boss makes an attack, it creates a state, a weak state, which only in this weak state will it allow the boss to be attacked and essentially get damaged. So can be attacked. So this is determined here. So long as there's a white star, it basically represents that, hey, I can be damaged. Because the boss uses a hard system and not a health bar system, I needed to restrict the player from just spamming the attack key and killing the boss straight out. As you can see here, there's this little cutscene movement. So this is actually done using a technique called time machine. And because I'm actually allowed in the animator to set two different cameras to two different animations. So if I want to play one animation, I switch to another camera. So how this is done is that I first of all have a separate cutscene camera that follows the player and is usually deactivated until absolutely necessary. Now, the reason why I didn't set this to the main camera is because of my camera follow script. Because if I were to have camera constantly follow the player, since they move on a tile by tile basis, a set distance every time an input is made, it would be incredibly dizzy for the player if they were to actually constantly follow. Now, and with that said, all I had to do was to put the capsule camera here Once they reach a certain area, which is pretty much this little space, and the collider reach this little space, all it basically does is that it says, hey, I've collided now. I'm going to say that, oh yeah, the object itself was deleted already. So what this basically does is that it switches to a different animation. And the moment it switches to a different animation, because these animations are bound to cameras as shown here, I effectively have this little camera move all the way to this little camera here. So I'll now be able to show, as you can see, the thing is in the blue line here. So once that's done, I delete it to make sure the player is unable to trigger it ever again. Game ends. Now there is also two more things. We have a camera follow script, which is actually fairly simple. Because they only move a set distance each time they make an input, I basically made it so that with this collider, with a collider that has been preset, I'm not too sure why it's not being shown right now. What this basically does is the player leaves the camera field of view, only then will it update the camera to show the player. Something a bit like, with Metroidvania. With Metroidvania games when they enter a certain area or section of the level. Now, last but not least, I'm going to be talking about a little bit of quality of life, which is basically a pause menu. Now, this pause menu is actually going to be important, mostly just to allow the player to exit the game, return to the home screen, and set options. Now, these options are fairly simple. We have a volume slider, which is basically linked to this little thing here. It's basically linked to this little thing here through a master main mixer. So this main mixer basically determines how loud the sound is going to be, and we have a resolution. Now, how exactly does this resolution work is not exactly very complex. So all this does is that it basically checks for every single options that is available. So for example, if the computer can support 100 times 100, 100 times 70, 100 times 60, 100 times 50, all of these resolutions, which is basically the scale of the screen, it stores them all in a list to be shown here. And if you were to select one of them based on its position in the array, it'll update the resolution accordingly using this set resolution thing. And this full screen is mostly just a toggle system. So all of this is fairly simple. It just goes through the loop to store every single option. So with that stated, ultimately, let's just talk about the final process. Okay, first and foremost, because there is a set distance that the player moves each and every time, because of how this works, having it be like this makes for a very messy script. Because I'm trying to draw multiple lines to detect something that might not actually be there by sheer interest. Mostly because of user error, since these portals are not actually perfectly aligned to allow the player to move on a tile by tile basis. They could be off by even the slightest amount, and it could throw off the entire debug, the physics 2D.draw away system. So hopefully what I could actually do is to create tiles. So if I were to look here, is to create something like this. Grab the player and basically have each tile registered and have the player move from this tile to this one. So I register it instead of having a set distance moving a set distance to here, because if it spawns here, it's going to move here. And if it spawns here, it's going to literally move back one space, which is going to be a huge problem. And if I were to register just a tile, it will always move from this tile to this tile, no matter where it is. So it always moves from the center of this tile to center of this tile. So if it's at the edge, it'll just move to the center of this tile naturally. So a second thing that I would like to state is that some of my code isn't exactly very robust. So in the event it does collide, there isn't a way to get the player out of any potential soft locks. Because if the player, for example, if you were to look at this little scene here, because some of these areas are actually damaged, the player cannot access them. So if the player somehow manages to get in there, there is literally no way for the player to get out, and they will be soft locked and they'll have to restart the game itself. So I would actually need to unfortunately account for that. So um, as for what's good really is the turn system, which actually allows me to expand on it a lot, because since this actually stores the list and goes down one by one, I can add as many enemies as I want and my system would just handle it just fine. And secondly, uh, since I've actually managed to combine a rhythm game with a side scroller, it's actually something new that the player might actually gain an interest in, hopefully. But since this is something a bit unfamiliar due to the way that this entire system works, I really need to actually set up a real tutorial level instead of having a help menu as shown here. Because players don't usually read these things according to my player feedback. So instead of having all of this stuff, I really like to convert it into an actual tutorial level. And with that said, I definitely would want to streamline a few things like options, since I would ultimately be better off changing some of the text for this, because sometimes you really cannot see the text well. There is a full screen for this, which is right here. Okay, yeah, start default volume. So with that set already, get that for the volume, full screen, the toggle. As you can see here, it's actually a lot more visible. So in terms of problems I've encountered, it's definitely the pause system for the rhythm mechanic, because everything moves in accordance to the pause system. So if I stop that, nothing else is really able to move. So what I would like to do is I would like to edit this code accordingly in order to make sure it just stops the entire system, and instead of just clearing everything, it just stops the node spawner and it resumes the beat like normal. So maybe what I can do is by having this move to center, this move thing, this little chunk of code, I could just have it wait for a bit before actually setting its move speed to 0 to give it some time to move first. But this would actually take a lot of tweaking to do. I could update the sprites, but that's not really necessary. And outside of that, I could definitely make the controls a bit more user friendly. So outside of setting a tile map, that's really just about it in all honesty. So fundamentally, when you play the game, you are mostly just given the minimap to tell you where to go. There's a story mode to guide you. Ultimately, there is a structured format in which this works. But sometimes, because of how the assets work, it doesn't actually mesh very well. But since that's not really very important, so that will be all for my devlog. I do hope you've been able to understand everything there is to know about my game, and I hope that when you actually play the game, you'll actually be able to have some fun playing the game. So this is Yoja Shen, and ultimately, once more, thank you for listening.